Hello, my name is Tom Stiles. Are you ready for some serious surgery? Yeah, we're going to move on with this broomstick antenna and see if we can get to the root of this thing, find out what is going on. So, I did some initial tearing up of this thing, and I cut the end of it off so that we can see down inside and try to figure out what was going on. And I did a quick test to verify that since we move these wires around, we didn't cause it to start working. And it's still not working, or it doesn't appear to be working. It seems like there's nothing really on the end of this antenna, and nothing connected to this connector. So we're going to get kind of drastic now, and I'm going to take that connector off. I tried to take this connector off, push it down inside, and then pull it up, and then I can see the back side. And I don't have a pointer, but we can see the back side of this connector right here. That's it right there, and it's got this black cap on it. And then I think down inside there is where the connection is to the center conductor. I just can't see it from where it is now. So it's time to dig inside. I'm going to get pretty radical here and make it or break it. So here we go. I'm going to do a quick check here to see if anything is shorted or whatever. So I got my little handy dandy meter here. And we're going to go on to ohms, and we'll move some of these tools out of the way so you can see the meter a little better. Take the protection off of there. Don't know if I can make contact down in. No, I don't think I can. So let's move the camera a little bit. There we go. And we'll zoom in a little bit for you. It's always when I zoom, though, I gotta watch that I keep what I'm working on in the field of view, which is not right now. So let's move the camera a little bit, and we'll see if we can slide over. There we go. Whoops. I can't slide over anymore, so we'll tilt the camera. And we'll push it back up. And that's about the best we're going to do. So then I'm going to take this handy dandy little tool called a paper clip. I'm going to jam it down inside there. See if it makes contact. And then we're going to even use this alligator clip lead. Need another hand is a problem, and I'm going to clip that on the end of this. That'll save me having to fool with that. And then we'll short my meter out to see if it's working. Trust me, it is. I know it's not in field of view now, but I'll just have to trust me. Okay, what we did before is we've got this heat shrink tubing over a piece of wire, and I think, and it's hard to see where it goes, but I think this is the wire that goes down inside the tube and is wrapped around the piece of wood or whatever is in there. And we've cut away. It's got a splice here. I don't know what the deal with the splice is. We've cut away some of the tubing here. And yesterday we were able to get continuity. Yes, we're still able to get continuity. So that indicates, let me set this down, that indicates that the center pin here on this connector is making contact with this heat shrinked tubing. It's actually a white wire with black heat shrink making contact, which my guess is that's the way it should be. Now, let's go one step beyond that, and let's check the center conductor again with the outer shell. And it's open, which it should be. It's open. So, my understanding, my guess, is that there's wire wrapped down inside this tube, and then it comes up and it's connected to the center conductor of this connector. Then that should be right. And therefore, right now what I'm seeing should be working. So, I don't know if I'm going to get very far here, because if I take this connector out and I just pull this up and it looks like that wire goes down inside, that's the way the antenna, I think, is constructed. So why isn't it working? What am I overlooking here? So anyway, let's turn my meter off, save the battery, get that out of the way. And now we got the handy dandy little wrench, and this is where it's going to get kind of radical. It may end all of a sudden here when I break something, because this nut on this connector is, it looks like it's got Loctite on it, which is an adhesive you put on things like this to keep it from backing out. And of course that's what we're going to try to do. We're going to try to back it out. So here goes. What the heck? All I can do is break it. Well, no, I can't break it because I think it's already broken. So we're going to go ahead. So we're going to see how much pressure we have to put on this little dude. And we're not. It's going to be, yeah. See that Loctite? That Loctite is doing its job. It's not letting me turn that connector, or that nut on that connector. So let's try going back in. And let's see here. Yeah, the whole darn thing's moving. So maybe what we could try to do is just flip the whole connector upside down here to get, because it looks like, to me, it looks like the connection goes down on the back of this connector. So that's why I can't see it, because it's on the bottom side, so I can't see it. So if I can rotate the whole darn thing, then maybe I can bring it up and see the connection. But again, it appears the connection from the center conductor to this wire here is there. Which is what it should be. So what the heck? Here we go. So now now it's moving on me. Now we're going somewhere. Okay. The nut's starting to turn or something. Yeah, here we go. Dun, 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 some music here. Yeah, see, there's the Loctite's flaking off. So the Loctite did its job, and I've managed to overcome the Loctite. This thing's able to go boing any minute now. Okay, now the whole thing turned there, and the whole thing went up. Okay, so now what was the pointing down is now pointing up, and I can see the back of this connector. So let me get my handy dandy magnifying glasses on here, and a handy dandy flashlight, and I'll probably be in your way to see this. And let me see. Whoa, does that ever look awful? It's soldered there, but it's really it's got some more of this clear, it's like silicone glue or epoxy. And let me get stand by. Okay, maybe I can zoom in a little bit for you and you could see this a little better. That's maximum zoom, okay? And I'm trying to use my arrows on my computer screen to point to it. I'm sorry, that doesn't work for you. Let me just get one of these leads. So here's the back of this connector, and here's the wire that goes up. And they've had to soldered these two pieces, this short piece and the piece that goes down inside the antenna. They've soldered those together and put this heat shrink tubing on it. Why they didn't just solder this directly to this, I'm not sure. I just don't know. I'm not saying they did the wrong thing. I'm just saying I don't understand why they did it like they did it. So anyway, there we go. We got this. Now the wire has come out, and I'm gonna stand by a while. Look down deep inside, and what do I see down in there? Okay, what I'm seeing is, what I think I'm seeing, get it back in the screen here, is this end here goes to the back of this connector. And it seems to be, when I did the continuity test, it seems to be wired correctly, and it's not shorted to ground. So that's cool. And so there's only one lead, and that's the antenna wire that goes down inside the broomstick. And there appears, and it doesn't show up very well for you, but it appears there is maybe a flat piece of wood, or even maybe square piece of wood that goes down inside that the wire is wrapped around. So that looks kosher. And then look some more, and there's even there's a little piece of paper with some writing on it, and it looks like X93 inches. X93 inches. So it looks rectangular. It's not a round dowel. And I can see, sure enough, I pulled some more out. Here we go. I pulled some more of this out just by pulling up on it, and it looks like this goes down and is wound around a piece of wood that's jammed down inside this thing. So, and then there's there looks like there's tape. There's tape. Ooh, that makes it too bright. There's tape that's around the perimeter or the outside of the wire. So you've got the piece of wood, looks like a rectangular piece of wood. Then you got this wire, this kind of wire here, wrapped around that, and then it looks like you've got black tape wrapped around that. So that looks like it's how it's constructed. Now, everything seems to be kosher as far as excuse me, the connections. I gotta get a drink here. Stand by. Sorry about that. Got a little sore throat. So we were able to rotate this connector so that the solder connection now is up, and I can see it, and this wire is soldered to the back of this connector. So I don't know where else to go from here. You know, I don't see any indication that anything as far as electrically being broken. I don't see anything broken here, and it does seem to be making connection to the center pin of this connector. So I don't know. I don't know what's wrong with this antenna. The only thing else I can do, which would be quite a bit of work, is to actually split this whole tube down and see how this is constructed and wound around. But that would be well, stand by for a second. The way that talking thermometer is set up is that I have the outdoor temperature probe, which is, it's just a wired probe, it's not wireless. I have it stuck up in the vent of the air conditioning, so that it gives me an indication in the summertime if the air conditioner is blowing cold air, and in the wintertime it gives me an indication that the air conditioning, or the heater in that case, is blowing hot air. And it also has an over temp alarm, and it's set at about 100 degrees. And so every time the furnace kicks on and starts blowing hot air out of there, which is probably 120 degrees, that alarm goes off initially. And then when the furnace kicks off, then it goes down below 100 degrees, and then when it goes up again, it kicks off the alarm. So that's the little intrusion we've had there. Sorry for that. So I think I'm kind of stuck here at this point with what I've got. Let me examine down inside myself here. Stand by. Yeah, I can see the. It looks like it's not a dowel, but it's a square piece of wood that just perfectly fits down inside this PVC, and it's got the wire, this white wire, wrapped around it. So I think that's the basic design, and I could pull a little bit more out. But I think that's it. So I don't know what else would be wrong with this antenna. It looks like basically it's a rectangular piece of wood with this gauge wire here wrapped around it, and then once it's done, that wrapping is done external, then it's shoved down inside of this piece of PVC. And I don't know what else could be wrong with it that it doesn't work. Maybe it's too short. Maybe, let's see, let me think about that. If the piece of wire was too short, even though it's wrapped around here, and I could probably do some kind of math here to figure out how long it would be given the size of the dowel and size of the wire. But maybe it's just flat too short. Let me see if I can find yeah, here it is. Okay, I've got my measuring tape. So let me just, I've never done this, let me just measure how long this tube is. Okay, this tube is exactly 3 feet. So I guess the question is, how much, where'd it go? How much wire, what length of wire could you wrap around this thing if you wrapped it perfectly tight and using this gauge wire? How long a wire would you have that, how am I trying to say this? I'm trying to say how long is that piece of wire? Now let's just make a wild guess. We got, if it was wrapped around nice and tightly, and we've got 36 inches here, say it's 3 times the length. So that's 3 times, let's even say 5 times. So it's 5 times the length of this tube because it's wrapped around. So say it's 5 times. And somebody can leave me a comment that what's a better number based on the diameter of the piece of wood and all that stuff. But say it's 5 times the length of the tube. That would be 15 feet. That would not be very long. That would not be long at all. That's like, that's up in the VHF band for, you know, a straight wire, because you know, if you're talking about 15 feet, that's just way too short. So maybe that's the flaw, that the basic antenna, the wire inside here is just not long enough. Now, I've seen, this is not a hoax as far as the design. I have seen in other publications, I've seen this type of antenna. They don't call it a broomstick antenna, they call it something else. But number one, it's about 8 feet long, and number two, it's smaller gauge wire, so you could get more winds around that dowel, whatever it is. And so say that you could get 10, well, maybe that's too much. Yeah, let's just say you could get 10 times the length of the wire times, I mean, the length of the dowel times 10. That's how much wire you could spool on it. And say it was 6 feet. So that would be 6 times 10. That would be 60 feet. So that's kind of getting closer to kind of the minimum length you need. Now, for instance, these antennas that you see that come on a little spool and you spool it out, they're about 23. Whoops, it just broke loose. That's interesting. But it was connected, so, you know, I'm not saying that that was the problem, but it was kind of interesting that it just broke loose when I was talking about it. But as you noted at the beginning, I measured the continuity, and it was making contact, which it should not be now since I just broke it. And, well, it's not making now, I know, because it's disconnected. Let me kind of examine it, see if I see anything. But it's interesting. Oh yeah, there's right there. Right, oops, let me get my glasses out of the way here. Right here, I can feel where it broke off right here. So there was connection there. So that wasn't the problem. But again, getting back, and I'm rambling here, getting back to what I think is the design. This is the size of the wire that's wound around down inside, I believe, because this looks like it goes down inside, and it's just wrapped around that wooden piece of stick, I'll call it. So that's pretty heavy. That's pretty heavy gauge. So you're not going to get a lot of turns. And my math, as far as trying to guesstimate how long that piece of wire is down inside here, could be totally flawed. But what did I guess? I guessed 5 times the length of the tube. So you get, so that would, the tube is 3 feet, that would be 15 feet. And that's almost making the minimum that you get with these little reel antennas that just have wire that's reeled around this little plastic thing, and you just stretch it out. And they're typically about 25 feet. So this could maybe meet that minimum length, but as we know, those antennas aren't that good. They give a little bit of an improvement over your telescopic antenna, but not much, depending on how long your telescopic antenna is. So maybe this this concept, or this actual design of this particular antenna, is just flawed from the standpoint that the wire that is wound around inside this thing is, if you stretched it out, is just not long enough to begin with. And like I say, I have seen other designs of this, and the dowel, or the broomstick, was about 6 feet long, and it was much smaller gauge. which means that you could get a lot more wire as far as length wrapped around that broomstick. So I think I'm going to call it quits on this, and maybe later on I'll actually cut this thing open, because I don't think I can make it work, at least not on HF. Now this antenna might work on VHF above 30 megahertz, or it might even work, right at 30 megahertz, and maybe it would be considered a 10-meter shortwave band antenna. Maybe it's just enough long enough to be used for 10-meter reception, or 28, 29 megahertz reception. So that's kind of it, unless somebody gives me some good ideas of what to try next. I'm just going to kind of hang it up on this darn broomstick antenna. And I don't want to say that it's not working, because I haven't done the full disassembly. Maybe there's still something wrong down inside there. Maybe it's, I don't know. This wire is this white wire that goes down inside. It looks like it's brand new wire, so it's not like it's old crumbly wire. And the connection was a good connection until I broke it fooling around with this. So it appeared that the construction, at least from what I can see, and of course I haven't gotten down inside, was okay. But it may be that the length of the wire is just too short for anything less than 10 meters or 27, 28 megahertz. I really never tried it that high, because I typically don't listen that high. So maybe that's the flaw, is that it's really not designed to work on the full shortwave band from, say, 2 megahertz to 30 megahertz. And I was trying it down to 10 megahertz and 15 megahertz, and it just was not working. Which is still, it's kind of puzzling that it didn't even do any better than a built-in telescopic antenna, which is, of course, you're talking 24 inches maybe tops. And it didn't even do as good as that. As you saw in my test before, where I tested it against the Grundig 450 telescopic antenna, which was, in one case, in the last test I did, I was getting WWV on 50 megahertz with that telescopic antenna, and then when I hooked up this external antenna, I got nothing. Now, because I was using the coax cable to bring that signal in, it reduced the noise, so you didn't get as much noise, but there was no signal there. And you do get line loss or signal loss when you go through coax cable, and that coax cable, I believe, was 25 feet. So maybe the little bit of amplification that I got from this antenna was canceled out by the length of the coax cable I was using to bring it in on. Now, granted, I was using, I believe, RGA 58, because the RGA 58 comes with this type of F connector, and maybe that's a flaw right there. And maybe the 25 feet of that cable, and it was brand new cable, but it wasn't expensive cable, so it wasn't the best in the world, and definitely had some loss. So maybe that loss in the cable wiped out what little gain that this antenna gave me, and that's why I saw no increase over the telescopic antenna. So anyway, that's about it. Oh, there it goes on the floor. Unless you've got some suggestions of what to try next, I think this is terminal. Yeah, we're at the end of the road here, and used up enough time trying to find out how to get this thing to work, and we're just going to call it quits for now. So thanks for watching. Tomorrow I'm going to do the video where I give away the radio, so that'll be kind of exciting, especially for the person that wins that Kato radio tomorrow in the drawing. So thanks for watching. Have a happy holiday. Bye-bye.